Hello, welcome to another whiteboard learning. Today is ISTAT Part 3, Anion Gap. Hopefully this will help just introduce the concept, but to be honest, this is an imperfect concept. And so even though it is on the ISTAT, I personally rarely use it. I don't find it that helpful, especially these days when we have a lot of testing that helps us figure these things out, that we don't really need it, but I do want you to understand what it is. And I apologize because the dog has a bone and is chomping on it in the background, so you're going to hear her acting a little crazy. All right, so let's first introduce the concept of cations and anions. So these are opposite. You may remember from chemistry that cations are positively charged chemicals, so elements. So these are positive. So the thing I learned in school was pos cat, neg, whoop, an. And that was how to remember which of these ones was positive and which one was negative. It's pos cat, neg, an. So cations are positive elements and anions are negative elements. So you might remember sodium is positive, it has an extra proton. Chloride is negative, it's deficient with one proton. So what are the major ones that we have in our blood? Well, we also have potassium. We have calcium, has 2 pluses. We have magnesium, has 2 pluses. And those are the major positive ones that are in your blood. Easiest to measure these, right, with the ISTAT, with the plain old ISTAT. And then chloride and then bicarb. They make up the majority of the negative ions that we have, elements. And then there's a few others though. So we have plasma proteins. So actually albumin and globulin are negative charges. That's why they sometimes get attracted to other things like sodium. And then negative things like lactate. So when that's high, that's negative, but there's always a little around, that's negative. It can become lactic acid, but lactate is negative. And phosphate, we measure that sometimes, right, in diabetics. Sulfate, another, there's some in your body. These are small amounts. And then acid things that can become acids, but the charge is different than their acid base, right? Remember that. Charge is not acid base. So ketones are negative. So the thing that's important about cations and ions is that they are generally equal in your body. So there is what is called electroneutrality, meaning the positives and the negatives have to be equal. So if that's true, then in the blood there'd be this much, and this would be equal. And that is true. The problem is that we don't measure them all. And so in the old days, 15, 20, 30 years ago, they came up with a concept called the anion gap to help you figure out what was going on if there were differences between them or perceived differences. So let's walk through that. So if sodium is the big cation in blood, right? We know that's 140. Potassium's about 4 milliequivalents per liter, 140 milliequivalents per liter. Then magnesium and calcium are here, but if we do an ISTAT, we don't normally measure those, so we're going to call them unmeasured cations, because on a regular ISTAT, we're not really measuring them. Now, what about anions that we're measuring? Well, we have chloride, but chloride's always a little lower than sodium. So chloride is, let's say it's 110 milliequivalents per liter. And then we're going to have bicarb. And so bicarb is generally about 20. Now, bicarb is not just important for being an anion, it's also part of acid base. And so that's where this kind of will head as we kind of think about it, acid base. So then there's unmeasured anions, and I drew this somewhat wrong. I'm going to fix this. So chloride, bicarb. Potassium, I'll make it smaller. There you go. So here's bicarb. So in a natural state, the unmeasured anions are always greater than the unmeasured cations. I didn't do a very good job drawing it. But these add up, if that's about 20, that adds up about 130, and this adds up to about 144. But generally, the difference between this unmeasured cations and unmeasured anions, the unmeasured anions are about 12 to 24 milliequivalents per liter greater. So the unmeasured anions are greater than unmeasured cations. That is the anion gap. And so when you're calculating, that's a calculated item, right? Because what did I do here? I added the sodium, I added the potassium, and then I subtracted the chloride plus the bicarb, and that gives me this unmeasured anions minus unmeasured cations, or the anion gap. And so it's really just math based on the ISTAT, because those things are on the ISTAT. But what does it actually tell you? So that's how you get to it, but what does it tell you? Well, if the easy thing is that if this gap is smaller, that means there are probably fewer unmeasured anions, right? We'll move this way. That the biggest problem is proteins. So your albumin is probably low, or your globulins are low, or something like that. But albumin is the big one. So the biggest reason, number one, for a low anion gap is low albumin. That's pretty easy to figure out. All right, so let's clean it up here. So say we have our gap, and let's say that the anion gap is increased. So that means this has moved this way. And that means that there's more unmeasured anions. Well, the thing that usually happens is that you have an acidosis and your bicarb is smaller. Bicarb being lower means that this base has been taken away by more acid. So that would mean you're more acidy. Now there's two ways of thinking about acids, and this is where anion gap was used. What if you looked at your pH and it was low, so that's an acid. Was your anion gap, was it, we'll use this over here, was it normal versus high? If the anion gap was high, that was supposed to tell you that there were more unmeasured anions. So you were maybe a diabetic who had ketones. Or also BUN is an anion, so BUN, maybe that was the reason it was high. Or maybe you had lactate. But these things didn't actually prove out to be very useful. The anion gap by itself actually didn't tell people that much, so most of us don't actually use the anion gap very much. One way that it could help you is if you know you're not a diabetic and it's early, ethylene glycol, antifreeze, will show up as an unmeasured anion, and that could help you potentially figure out that someone has antifreeze poisoning, but we have a test kit for that. So even though anion gap is on here and you can look at it, it's really not that helpful for the general emergency doctor when I can actually measure these things. I can measure ketones, I can measure lactate, and I don't have to guess. So a lot of people have moved away from this. But I hope that it helps explain it a little bit. And if you have any questions, let me know.